All right, this problem, it says if a and b are positive constants, and then the limit as x goes to infinity of this expression is equal to what? So it's tempting, a lot of students I think are tempted to pick answers like infinity because they may, again, if you evaluate, no, again, you can't evaluate something at infinity, but let's just say we can, right? They say, well, that's infinity, and then, oops, infinity squared. Doing this probably leads to more confusion than anything. So in any case, you do something like this, maybe you don't know where to go from here. The thing is, so the natural log graph is an increasing graph. So as x gets bigger, the natural log of anything, anything involving x, whether it's just x or bx plus 1, bx plus 1 is going to get bigger, so natural log of that expression is going to get bigger. In any case, that's going to infinity. Same thing here. This is going to infinity. And so this is called an indeterminate form, and that means we can use L'Hopital's rule to evaluate this. So L'Hopital's rule says that that limit, the original one, is the same as the limit of the derivatives of the numerator and the denominator. So the derivative of the numerator would be 1 over bx plus 1. That's the derivative of log. And then times b because of the chain rule. And then the denominator would be 1 over ax squared plus 3, and then times 2ax. So I'm going to sneak that in here. Okay, times 2ax because of the chain rule. And then let's maneuver this around a little bit and see if it helps. So this would be the limit as x goes to infinity. So I got a fraction divided by a fraction, so why don't we write that as b times ax squared plus 3 divided by 2ax times bx plus 1. Okay, again, I just multiplied by the reciprocal of this denominator, and so that's what we get. Okay, and so what now? Again, maybe, so at this point, notice we're not dealing with ln anymore, so that's useful. If I distribute this, I get ab x squared plus 3b, and then the denominator I get 2abx squared plus 2ax. So this is a rational function, and at this point there's a couple of approaches you could take to get to the right answer. One is to notice that this is just going to be the ratio, this end behavior is going to be the ratio of the leading coefficients there. So it should just be ab over 2ab, which is 1/2. Okay, so the answer is 1/2. If you didn't catch that, you can also use L'Hopital's rule again, because I still have, this would still be an infinity over infinity form. As x goes to infinity, both the numerator and denominator go to infinity. So you could also use L'Hopital's rule again if you really wanted to make it clear. And watch what we get when we do that. So then the denominator becomes 2ab x, 3b, remember, that's a constant, so that vanishes. And here I'd have 4ab x plus 2a. Okay, again, you could use the same reasoning here. This is the highest power, the lead coefficient's 2ab, lead coefficient's 4ab, so again we get 1/2, but I'm just kind of trying to show you, you could L'Hopital's rule this the whole way if you really wanted to. So now it's 2ab over 4ab. Finally, you end up with your 1/2. Okay, so again, there are a couple other, couple exits you could have taken in this problem to arrive at the answer, but in any case, it should be 1/2.